Black holes, wormholes. Both sound like something straight out of a science fiction movie. But did you know that one of them is absolutely real and the other is still just a theory? Today we're diving deep into space-time to explore one of the most fascinating questions in astrophysics. What's the real difference between a black hole and a wormhole? Buckle up, because this journey will bend your mind impossibly. Time itself. What is a black hole? Let's start with what we know for sure. Black holes are real. They're not just theoretical. They've been observed by scientists and even photographed, like the famous image of the black hole in galaxy. M87 captured in 2019. They form when massive stars collapse under their own gravity after running out of fuel. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape its pull. At the center of a black hole is something called a singularity, a point of infinite density where the laws of physics break down. But shortly after, you'd be stretched, crushed, and essentially erased from existence. Surrounding the singularity is the event horizon, the boundary beyond which nothing can return. If you cross the event horizon, you wouldn't even notice right away. Black holes come in many sizes. Stellar black holes. Formed from stars, intermediate black holes. This is why wormholes are often imagined as tools for faster-than-light travel, or even time travel in science fiction. And supermassive black holes, like the one in the center of our Milky Way galaxy. Millions of times more massive than our sun, according to current theories. Wormholes would collapse instantly unless held open by something called exotic matter, hypothetical substance with negative energy. And we've never seen exotic matter in real life. What is a wormhole? Theoretical. Imagine bending a piece of paper to bring 2 points closer together and poking a hole through that S. What a wormhole does. Connects distant parts of the universe, or even different universes, through a tunnel-like structure. Now let's talk about wormholes. Unlike black holes, wormholes are still theoretical. They exist in the math of Einstein's theory of general relativity, but have never been observed in real life. A wormhole, also called an Einstein-Rosen bridge, thought to be a tunnel or shortcut through the fabric of space-time. Theoretically, you could enter one end of a wormhole and emerge somewhere completely different instantly. But there's a big problem: stability. So while wormholes are possible on paper, we don't yet have the evidence or the technology to prove they exist. Key differences between black holes and wormholes. Let's break down the main differences between these two cosmic phenomena. 1. Proven versus. Black holes are real. Wormholes are still unproven. 2. Formation. Black holes form from collapsing stars. Wormholes are predicted by equations but don't form naturally in known ways. 3. Behavior. Black holes consume matter and trap everything inside. Wormholes could hypothetically let matter pass through and emerge elsewhere. For observability, we've observed black holes through X-rays, gravitational waves, and even images. Fascinating, yes, but not confirmed. Others believe that in the early universe, under different physical conditions, wormholes might have formed and survived. Wormholes? Nothing. No visual or physical proof. 5. Purpose. What if, instead of being a dead end, a black hole was the entrance to a wormhole? Black holes are like cosmic vacuum cleaners. Wormholes could be portals, allowing rapid travel through space or time. There's no observational proof. For now, entering a black hole still means certain death. In simple terms, a black hole is a one-way street to oblivion. A wormhole could be a shortcut to somewhere else if it actually exists. Could wormholes be real? Despite being unproven, wormholes aren't just sci-fi fantasy. They make for great storytelling, but in reality, we're not there yet. Einstein and physicist Nathan Rosen first proposed the idea in 1935. And since then, wormholes have been explored in various areas of physics, including quantum theory, string theory, and general relativity. They might be shortcuts through the cosmos, or they might just be mathematical fantasies. The other reminds us of what we might one day discover. Some theories suggest that microscopic wormholes may exist at the quantum level, tiny and unstable, popping in and out of existence. There's also speculation that an advanced alien civilization could potentially build or stabilize a wormhole using exotic matter. But again, this is speculation. Are black holes actually wormholes? here's where things get really weird. And never stop asking big questions. Some physicists have theorized that black holes could actually lead somewhere. This would mean that falling into a black hole might not crush you instantly, but instead send you through a tunnel in space-time to a different point in space, or even a different universe. There's even a theoretical counterpart called a white hole, a reverse black hole that can be entered from the outside and only emits matter and energy. But again, all of this is based on math and imagination. Sci-fi versus reality black holes and wormholes have become icons in pop culture, featured in movies like Interstellar, The Black Hole, Stargate, and countless others. Interstellar, in particular, did an excellent job portraying a scientifically accurate black hole, thanks to guidance from physicist Kip Thorne. Wormholes, on the other hand, are often used in fiction as a way to explain time travel or instant teleportation. So what's the real difference between a black hole and a wormhole? Black holes are proven, powerful, and dangerous. They are the real monsters of the universe, places where gravity wins over everything else. Wormholes are theoretical, mysterious, and full of potential. Both bend our understanding of space and time. One shows us the limits of the universe we know. If you found this video mind-blowing, don't forget to like, subscribe, and hit the bell icon for more space and science content. And let us know in the comments, do you think wormholes could be real? Or are they just sci-fi dreams? Till next time, keep looking up, L-Tools.